Alright, so now that you've spent some time going over how to do transformations and mapping rules, we're going to look at how we can apply that to find domain and range of a lot of the functions we've been looking at so far in the course. So before we get into that, a couple of things that you're going to need to know before we go into this lesson is, number one, make sure that we still understand how to do mapping rules. Okay, so we're going to need those a lot for this lesson. And all those parent functions we started at the very start of the year, I had to do some graphs of table of values. There was a lot of them, like we had y equals x squared, we had y equals 1 over x, absolute value of x, root x, 2 to the x, and so on and so forth. There's a whole lot of them. We're going to need to know what those functions look like and their domain and range. Okay, so keep those handy, and that's going to be something you're going to need to commit to memory in order to be successful, not only in this unit but later on in the course. Okay, but before you go about searching for that worksheet and all those graphs, let's quiz yourself a bit first. So here's a whole bunch of different parent functions that we've looked at, that you looked at in the first day of class. Try and picture them in your head, or do a quick little sketch and try and tell me what their domain and range are. Okay, so give a minute to try and fill in this chart, and push play and go through it together. Okay, and there you have it. So hopefully some of these are come to mind pretty quickly. Like y equals x is the standard line that you've seen way back in grade 9. Y equals x squared you've seen a lot of back in grade 10. So you can see their domain and range from there. The big new ones that we looked at this year, we did the absolute value function, y is the absolute value of x. So if you remember what that looks like, picture the line y equals x, everything that was below the x-axis gets reflected above. So it has this kind of general shape. So your domain is the x element of the real numbers, but your range is y is greater than or equal to 0. Another one that we looked at was y equals root x. Okay, reminder that looks something like this, like the top half of a sideways parabola. So you have this for your domain and range. 2 to the x is an exponential function. We're going to look at a lot more of those later on in the course. Looks something like this. And picture there's an invisible line called an asymptote. The graph gets infinitely close to but doesn't actually touch. So your range is simply y is greater than 0, not greater than or equal to 0. And 1 over x, which looks a little bit strange as well. We have asymptotes at x equals 0 and at y equals 0, and it has a shape that looks something like this. Okay, so you need to have an idea what these parent functions look like, as well as trying to figure out their domain and range. So once you have this picture, you can very clearly see the domain is x cannot be 0, and the range is y cannot be 0. We also looked at sine x and cos x, but we're going to spend a lot more time looking at those later on in the course, so you're not going to see too much of those today. Okay, before getting into something that's completely brand new, let's take a look at some questions that would look a little bit familiar to us based on what we've done so far. So here we have a domain, two problems that we want to find the domain of, and each of them are transformed versions of our parent functions. So in this particular one here, this is a transformed y equals root x. Okay, so we do some transformation to it, we wind up with this one, and the second one over here is transformed from y equals 1 over x. Okay, but for now, the way we used to do this is, okay, well, in terms of a square root problem, and trying to find the domain, we think, okay, what can we not do, right? We have a square root, what can we not do with a square root? Well, we can't take the square root of a negative number. So what that's telling you is that what's underneath the square root here, the 4 minus 7x, if it's going to be something valid that we can put inside the function, this has to be greater than or equal to 0. Again, because if it's negative, we can't take the square root of it. So what we have here is just an inequality that we can solve. So we end up with negative 7x is greater than or equal to negative 4 when we subtract 4 from both sides. And then we divide everything by negative 7. And remember, in an inequality, when you divide or multiply by a negative number, that the direction of the inequality changes. So you have for our domain, x is less than or equal to positive 4 over 7. And you can see on Desmos how that will be the case. Okay, you have about 4 over 7 down here for an x value, and it's anything to the left of that. Okay, for this next one here, so we have a reciprocal function here, and we're looking at what's in the denominator here. So what can we not have in the denominator? Well, we know in the denominator of a fraction, we're not allowed to have 0, because we can't divide by 0. So we can't have any x value that makes the denominator 0. What x value would that be? Well, we can just set up our denominator here, 9x minus 5. Set equal to 0, and then solve for x. So what we're saying here is that when x is equal to 9/5, okay, the function the denominator here is going to be 0, and which means you're going to have 1 divided by 0, which can't exist. So what that tells us for our domain is that x cannot be equal to 5 over 9. Okay, and these are types of problems we did back when we were first learning about domain and range. But notice with a problem like this, we've only ever asked you to do the domain. Okay, so you have to have a different approach to finding the range. So let's think about how we can also look at finding the answer to this kind of problem. So I want you to picture is, remember what a mapping rule does, right? It tells you algebraically what happens to all the x and y values from any point on the original function to go to your transformed function. Now, picture that if we know what the domain and range is of the original function, we could then figure out where those boundaries, if you want to call them for lack of a better term, get transformed to using the mapping rule. Okay, so before we start with a new example here, let's go back to this previous one and try doing this exact same thing, potentially using a mapping rule. So let's just say we were to look at the mapping rule that went from y equals root x to this transformed version right here. Well, hopefully it wouldn't take tons of work for you to figure out. But let's try it. So for what happens underneath the square root, that's what's going to affect our x value. So to create our mapping rule, remember x gets multiplied by -7 first, and then we add 4, okay, which means for the inverse, we're going to subtract 4 first, and then divide by -7. Okay, so for our mapping rule, we're going to wind up with xy being mapped to x minus 4 over -7, and then y minus 9. Okay, now, looking at this parent function here, y equals square root of x, we should know that from y equals square root of x, we know the domain of that is going to be x is greater than or equal to 0, and y is greater than or equal to 0 will be the range. So now, let's take this x is greater than or equal to 0. More importantly, let's take the 0 from there, and sub the 0 into the mapping rule. Let's see what happens to it algebraically. So we take 0, we subtract 4, which gives us -4, then we divide by -7. So that tells me that my 0 moved to +4 over 7. Okay, so that will be my new boundary for my domain. Now the question is it going to be still greater than or equal to, or will it have switched to less than or equal to? Well, remember here, as we move through this, when 0 minus 4, we divided by a negative right here. Remember when we divide by a negative, we change the direction of the sign. So now it's strictly gone from greater than or equal to less than or equal to. And if you remember, that's the same answer we got when we did this the other way. Okay, so we have two different ways of getting the domain of this type of problem. If it's a square root function, you can take a look at what's underneath the square root, make sure it's greater than or equal to 0, or we can use the domain and range, the original domain, and plug it into our mapping rule. So let's see how this works for the range. Okay, so for the range, my original boundary for the range is at 0. I plug it into the mapping rule. 0 minus 9 gives me -9. So the question is, did my sign change directions? Well, in here I didn't multiply or divide by negative. I subtracted something, sure, but no multiplication or division by a negative happened here. So I would still stay at y is greater than or equal to -9. And just to confirm by looking at our graph on Desmos again, we can see that y equals -9 is the lowest value this graph reaches. Okay, so two ways of finding out the exact same problem, except this new method here lets us get the domain and the range, whereas previously we could only find the domain. Okay, so now let's try and use that method and try and figure out the solution to this one. So we're given that the parent function is y equals x squared. Okay, and this is our transform function. Let's try and figure out the mapping rule. Okay, so inside our function here for x gets divided by 3 because it's x times a third, and then we subtract 5. So for our mapping rule, we're going to add 5 first, and then multiply by 3. So for your mapping rule, you should get x plus 5, then times 3, and then -2y plus 4. Okay, so now let's use that to find the domain and range of our transform function. Okay, so what you're going to want to do first here is take a look at our parent function and find the domain and range. So our original domain for y equals x squared is going to be x is an element of the real numbers. Our original range is going to be y is greater than or equal to 0. Okay, and again, this is something you should know from knowing what y equals x squared looks like. Okay, so now let's take that and plug these restrictions into our mapping rule. Now for x, there are no restrictions, right? X can be anything, x can be any real number, so that's not going to change anything, right? No matter what you do to this parabola, whether you stretch it, compress it, reflect it, shift it, whatever, it's not going to change the fact that x can be any real number. So we don't do anything for the domain. That's going to stay the same. Okay, and there you have it there. Now for y, let's take that boundary, so we know y is greater than or equal to 0, and put that in the mapping rule for y. So negative 2 times 0 is 0, plus 4 is 4. So for my range, I'm going to have y, and I know the boundary is going to happen at 4. The only question is it going to be greater than or equal to 4 or less than or equal to 4? Well, let's take a look. Here, when I put in the 0, I multiply it by negative 2. Now I know 0 times negative 2 is still 0, but the fact that I multiplied by negative here, knowing my rules of inequality, should change the direction of that sign from greater than or equal to less than or equal to. Okay, so this should be the domain and range of your transformed function. Okay, now just to confirm, in part 3 it says to find the equation of the transformed function, which is really just applying function notation to everything that we have here. So if we know that f of x is equal to x squared, okay, and we're trying to rewrite this function right here in terms of our parent function, well, what are we really doing here? Well, we're going to have y equals negative 2. Now, f of x is x squared. So but instead of f of x, we have f of 1 over 3x minus 5. So we're going to have 1 over 3x minus 5 all squared, and then I can put in my plus 4. So this is your answer for part C. This is the equation of the transformed function. Okay, and you can see from looking at this that the a value of this parabola is negative, so it's going to be opening down, which again gives you just a bit of confirmation here that your domain should be y is less than or equal to 4 instead of greater than or equal to 4. Okay, so again, just to summarize here, what you're going to need is your domain and range of parent function. You're going to need a mapping rule. Okay, and then you're going to use the mapping rule. I'll use MR for mapping rule, and the domain and range to find the new domain and range. Okay, and this is a process that will work very, very consistently. So here's another one I'd like you to try. Okay, so same principle as the first one here, except this time our parent function is root x. So I'm going to let you think about what the domain and range of that one are. Okay, find a mapping rule and use that mapping rule with your original domain and range to find out your new domain and range. So give that a try and push play when you're ready to go through it together. Okay, so take a second to check your answer here. So for my original parent function here, root x, the domain is x is greater than or equal to 0, and then the range is y is greater than or equal to 0. For my mapping rule, remember, first thing that happens to x here is it gets multiplied by negative 1, and then 7 gets added to it. If you're having trouble seeing that, remember this is the same thing as negative x plus 7, right? The negative is attached to the x, and the 7 is positive. So x times negative 1, then plus 7. So in reverse or in inverse, we go x, we subtract 7, and we divide by negative 1. So we get x minus 7 divided by negative 1. For the y, it's just simply negative 3y minus 6. So you take your original domain, which in this case is x is greater than or equal to 0. You sub the 0 in. So 0 minus 7 is negative 7. Divided by negative 1 is positive 7. Okay, so that tells me that my domain has something to do with 7. That's where my boundary is. Now, the one thing you have to note here is I, again, divided by a negative, so that changes the direction of the sign from greater than or equal to 0 to less than or equal to 0. So you have to keep in mind that that could happen. Okay, so for my range, same idea, put the 0 into the mapping rule. 0 times negative 3 is 0, minus 6 is negative 6. The direction of my sign, what I'm looking at here is, again, this was multiplied by a negative, so the direction of the sign changes from greater than or equal to less than or equal to. Okay, so again, all you need was the original domain and range and your mapping rule, and you were able to get your new domain and range. Okay, now for the equation of the transformed function, we're applying f of 7 minus x to root x, so you should wind up with negative 3, square root of 7 minus x, and then minus 6. Okay, so this next one I'd like you to think about a bit. All you know about the original function is its domain and range. You can see its domain goes between negative 12 and 10, and its range goes between negative 5 and 17. I'd like you to find the domain and range after it undergoes the following transformations to get to these new functions. So give those a try, and we'll see you over in part 2.